Let's start our lecture. Today we will be talking about steel, buildings, and structures. Actually, construction is one of the most important steel using industries. According for more than 50% of the steel demand. Building from houses, car parks, schools and skyscrapers rely on steel of their strength. Steel is also used on roofs, claddings, exterior walls, and of course like building construction materials. As we know that the world's population is expected to increase, and so every year it increased for various percentage, and it will be increased, and nearby 30 years it will be about 10 millions in 10 billions in 2050. So that's why the steel was one of the really very quickly grows type of material which I use nowadays. This a need of steel actually in buildings and infrastructures actually continuously grow up in the worldwide. And we need to improve many things like reducing consumption of natural resources, reduce emission during the production of steel, and also try to create the future sustainability by using the steel. 1 minute, please. Okay, as we know, steel nowadays used like during construction buildings and so infrastructures. Not only affordable, still affordable and available, and also safety and many other properties like strength, durability, and 100% recyclability allow for improved environmental performance across entire life cycle of all type of the buildings. Advanced high strength steels used in the steel plate applications, also used in a number of related industries too, like offshore oils, bridges, various civil engineering, construction machines, railways, tanks for nuclear production, hydroelectric stations, hydroelectric plants. So all this is application which are used nowadays still like one of the most important materials, and sometimes just there cannot be used any other type of materials like steel according to these characteristics like I told you above. If we'll start talking about benefits of structural steel, we need to talk about the first thing. So we know that today, particularly all industries have the major application of the steel. From industry equipment to finished products or ready products, structural steel nowadays are used everywhere. So this is mainly because innumerable benefits of structural steel provides it. That's why I want to focus you on the several advantages, benefits on the building materials. So first of them is that steel can be easily fabricated and produced massively. So actually steel sections can be produced off-site at the special plants and shops, fabrication shops, and then assembled on-site. So this saves time because there are no reason to use additional installation processes.
Sorry, Alexander Alexandrovich.
Yes?
We can hurt you. Maybe you up your voice, and or can you talk a little louder? Not so
Okay,
loud.
okay.
Yes, super.
Okay. So, as I told you that the first of the advantages of the steel, it's easily fabrication and produced massively. So it means that steel constructions can be produced off-site, so on the special plants and on the special shops, and then assembled on the construction site. Actually, it saves time, it increases efficiency of all construction processes and the overall all construction processes too. It's actually very easy to produce it at the special plants and shops because it will be not only save time but also will increase the safety characteristics because you can control many parameters during production, steel materials and so on. You can control the temperature during production and so many other special characteristics which gives you first of all safety and second opportunity says that it will be a really high quality material. Steel also is a tensile material. It has the higher strength and weight, higher strength to weight actually in ratio, strength to weight, yes, which means that it has higher strength per unit mass. So matter that large overall structures is steel sections, and it will be small and lightweight until other building materials, for example, masonry construction, monolithic concrete construction, just concrete construction. Structural steel is a flexible material. It means that you can mold it into various shapes and types of material without changing its properties. Also, you can convert it into sheets or turn it into wires according to the architectural design. That's why it's became very popular for the modern buildings and for non-traditional building materials, like non-traditional building materials. According to the costs, structural steel is relatively cheap, actually in compare with the other building materials, but not actually the cheapest, but in the same time, according to other above that I told above characteristics, they show actually can save resources during construction, according to the benefits. And the durable, so durability of material. So because structural steel constructions can withstand the higher external pressures and loads such as earthquakes, thunderstorms, cyclones, what else? So actually many, due to many disasters. A well-built steel structures can last up to 30 years, approximately 30 years, sometimes more, sometimes less, if maintained well. So we see the Eiffel Tower standing more than 100 years, and I think that it was well built because it still nowadays looks very well, and my not only many scientists says that it will stay many time. Like advantages, there are also disadvantages in this structural steel. We can't say that only benefits and there are no minuses, of course, like for all construction materials it has it. First of all, I want to say about maintenance cost maybe. So steel structure or so the main cost of steel structure is very high. So due to action of rust in steel, expensive paints, which we need for many purposes actually, and required to be renewed after time to time. So especially if the steel construction are used in open air. So it acts by the air, of course, it should be time of time repaired or renewed. So that resistance against zero conditions increases actually. Steel has a very small resistance against fire. So that's why in comparison with the concrete, for example, not so high temperatures, actually in comparison with the other materials, about 600 or 700 of the temperature degree can reduce the steel strength. Steel cannot be molded in any direction we want. So according to the design solutions, it can be really molded in various shapes. Of course, first of all, it should be right designed and analyze it. So to accept the right sections to accept the right mark of the steel and so on, to prove that the such design, the such construction will withstand all loads, applied loads, and it will work correctly on the construction site. That's of course important thing. If steel loses its ductility property, that chances of brittle fracture increases. So brittle fracture is one of the biggest problem for steel constructions, because during it became brittle, it can lead to failure for all structure. Because, for example, the brittle of one column or one beam can lead to failure of whole building. That's why is it very important to make the right analysis and finding the right thicknesses and sections for bearing steel elements. If there are very large variations of tensile strengths that leads to still more tension. So due to which steel tensile properties grab falls down. Also, I want to say about expensive waterproofing systems, because steel is not fireproof material, we know it. And of course, to protect it from the fire, we need to use very expensive protecting painting materials, which are also one of the minuses of the steel construction system. What else? So the steel has higher expansion rate. It's also right when the temperatures is changing. So when there are quickly changeable climate, so maybe will be, if possible, to use maybe some protection layers which will protect steel from the directly cooling or from the directly heating, and so we need to protect it. Unique aspects of steel construction. So the most important thing of using steel, it is that can be fabricated off-site, so both left. In the beginning of our lecture, I told about you that one of the advantages, it is fabrication. Fabrication nowadays can be like for single bearing elements, and so for whole levels, so all stories. For example, one story just at all can be designed and fabricated in the shop in general conditions, and can be transported on the construction site and just installed it. Of course, it will save time, it will save labor costs, it will gives opportunity on the quality of construction and so on. On-site erection is a rapid processes above right. So in comparison with concrete, one analogs, we can say that the steel construction is more rapidly designed and installed processes than others, because here we need to use not so many not so labor cost. We just needed several persons in the brigade, which will accept the beams, which will connect them, and one of the geodesists who will check the verticality and the horizontality of the beams and the columns. That's important. Schedule advantages, one also of the important thing, because reducing time of construction in general reduce the overall cost of the building. That's also important thing. And if we'll compare, for example, with the concrete monolithic construction, we find that time of construction is needs the more expenses for the salaries for people, and for other um, for
Александр Александрович,
oh yes, yes.
могли вы бы демонстрацию экрана опять включить и выключить и опять включить, а то не показывает, старый слайд стоит.
Okay. Sorry. Okay.
Все, спасибо.
Спасибо.
Okay. Types of connection in steel elements. So connection of the steel elements is an important thing during the installation of steel constructions, because most of the failures, most of the problem can be found in the connection. As we know, the beams and columns, for example, they are designed, can be designed well, can be produced well, but if their connection, so on the construction site, will be poor, it can lead to it can lead to failure of all building for all structures. What does it mean? So it means that we need put a really high attention about how will be done the connection. We need to apply the right type of connection. After then, we need the right understanding about choosing type of connection and so on. And that's maybe also very important to make the analysis of the connection. Nowadays, we are apply only type and sections of the main bearing elements, but we are not included into the analysis of the connection. But connection also should be designed well. So if we're talking about types of or classifications, we see that there are various classification of connections. It assists with the design of steel, choosing on, and the choices is based on practical considerations. So in general, it can be classified into 5 main categories. So in modern time nowadays, actually, the most common types is connecting mediums are welds and bolts, but also sometimes can be find the rivet connections. So rivet connection. So riveted connection. Rivets have a really long history connecting connecting medium for steel connections, because they are made up of head and ductile body, so shank. The processes of installation is preheating the rivet and the application of its pneumatic pressure. So it's pressed by the pneumatic pressure. So this posts a number of actually disadvantages, including the special equipment for preheating, extra energy input and processes, as well as fire risk, and also high levels of noise during its installation, difficulty in replacing during maintenance. So that's why nowadays not this type of connection can be meet not so often like previous to ones. Next type, it is bolted connections. Bolted have largely replaced than rivets due to the low installation cost, easy of installation and maintenance, and so on. Two types of bolts commonly used in the construction included the higher strengths of steel and the common bolts. So high strength bolts and the common strength bolts. They are divided into the groups, group A, group B, according to the strengths. However, bolts actually have the notable disadvantages of losing under the vibratory loads, resulting in reduction of the strength. So actually, again, we need to know in what type of constructions the bolts can be used, like one of the main type of connections. Sometimes actually can be used variations like combined methods, bolting and welding, but we'll talk about it some later. And the third and one of the popular type of connection, it is a welded connection. It's a primary advantage of being a simple design. It require few parts and the materials. So as you see, there are no additional materials. Welds, however, shrink, and this effect need to be considered. What is one of the problem during inspection of the welded constructions, which can lead to many problems. By the way, the inspection of the welds, it's more difficult, and hence and repair works, it's also not very easy. That's it's like a disadvantages of welding. Variability actually exists, the quality of weld. It's according to the professionalism of erector. The most often useful types of welds include fillet weld, groove, and plug. So that's most often useful types of the welded common types. The next type of the connection is internal forces, the connections expected to transmit the load. So it can be divided into the moment connection, shear, and actual connections. So how they work? one of the most important consideration when the designing a steel when we design the steel connection, uh, we need to base it onto internal phase in the connection and how they will transmit all the loads. So statical loads, dynamical loads, and so on. So right understanding of the applying loads can classify the connections like axial, axial connection, shear connection, semi-rigid. So shear means a semi-rigid connection, and moment connection. It is absolutely rigid connection. So without any permissions to moving according to all of axis in the construction. So what a rigid connection I told you, and in sometimes it carry out most of the weight. So in comparison with the two others, so moment connection. So on the screen you see the moment connection. It is a structural engineering joints that allows to transmit allows to transfer of bending moments forces between the vertical column and the horizontal beam, or sometimes other two members, maybe beam to beam, and the column to column, for example. If beam has some internal moment, the connection should be able to transmit the load due to the movements. Structural engineering, a shear connection. So I told you semi-rigid connection is a joint that allows for the transfer the shear forces between two members, like beam to beam or guider with the beam. So if the beam has some internal shear forces, it will be passed on the axial forces into the column member. So through the axis, the central axis of a beam, it transferred to the central axis to the guider. So we call it like shear connection. So connection types and location of actual restraint in steel beams. In picture you see the single plate shear connection and the welded angle seat connection. So the type of structural elements make up a steel connection is a common classification. There are many different types of structural elements. They can be divided into various placement as like results in many different many different connection types. So you see that it can be web angles, it can be seat angles, can be flats, plates, and so on. So many steel elements can help us create the right designed connection, right designed joint, which will carry out designed loads. So classification of the connections also commonly made to structural members that they connect, like beam to column, beam to beam, and column to column, column base plate connection, and so on. So in fact, consideration of connecting column and beams should act one of the primary consideration when needing design the steel connections. And of course, they are divided into the common configurations, like you see on the slide. Generally, full strength beam to column connection are designed to ensure the plastic hunch formation of the connection in the beams, and it avoid increase the plastic deformation in the column. Also, all components, it's a plate, stiffnesses, all diameters of the balls, all are need to reduce the plastic deformations. So we have less than 1 minute. Actually, this lecture will be continued, not end of this lecture, and we'll do it on our next lesson. If you have some maybe questions,